In this video, we will be talking about energy diagrams. Let's consider a typical energy diagram, which would look something like this, with energy on the y-axis and reaction coordinate on the x-axis. The reaction coordinate is not a measure of time, but rather where in the reaction a set of products and reactants are. Energy goes up as we go up the y-axis. So let's consider this typical energy curve, for example. And here we might have the reactants. Here we'll have the transition state, which is typically denoted by this symbol. And here we'll have the products. The reactants is what we start with, and the products is what we end up with. In order to get to the products, reactants have to overcome this energy barrier, which is called the activation energy. The change in energy of the reaction is this quantity. Because the reactants are at a higher energy than the products, we can see that this reaction has to be exothermic. You can sort of think of the energy diagram as a roller coaster ride. To get to the top of the hill, you need a lot of energy, but once you're at the top of the hill, you can rapidly fall down into the other side. Let's consider another energy diagram. That might look something like this. Here we'll have our reactants, and here we'll have our products. And once again, here we will have our transition state, and as we can see, the change in energy here is our activation energy, and the change in enthalpy will be equal to the difference in energy between the products and the reactants. Because this time the reactants is at a lower energy level than the products, we know that this reaction is endothermic and that delta H is greater than 0. Let's review some of the things that we talked about. If the products are lower in energy than the reactants, then the reaction is exothermic. If the products are higher in energy than the reactants, then the reaction is endothermic. Remember that a reaction favors going to a lower energy, so an exothermic reaction is more favored than an endothermic reaction. Reactants need to overcome the activation energy for the reaction to proceed. That is, reactants need to gain enough energy to get to the transition state in order for the reactants to turn into the product.